Now we want to try this in the playground, and we won't use the publicly available playground because that's outdated. That's from February, I believe. We want to use one that is in sync with the version of Plutus we are using right now. So we go back to the Plutus repository in a Nix shell to the subfolder Plutus -playground -client, and we start Plutus playground server there. Then we go to a different console, but the same folder again in the Nix shell, and we do npm start to start the playground client. And then we can open this address in a browser and find our playground there. So first we will see the editor window, and we can just take the code we just looked at and paste it in here and press compile to compile it. And if all goes well, that should compile without error message. It does. Now we can go to simulate, and here we have simulated wallets and can invoke endpoints. So by default there are only 2 wallets, but if we want to replay the scenario I showed in the EUTXO diagram, we should create a 3rd wallet. And we see that by default the opening balances are just 10 Loveless and 10 of this token. But I want this token to be an NFT, so that doesn't make any sense anyway. So let's say wallet 1 is Alice, wallet 2 is Bob, and wallet 3 is Charlie. So Alice has the 1 T, and that's the only one we have. So for the others, I say 0. And 10 Loveless is of course ridiculously low. So make that, I don't know, 1,000 ADA. So 1 ADA is 1,000,000 Loveless. So 1, 2, 3, 1, 2, 3. Let's give everybody the same. Okay, so now we can invoke endpoints. So Alice starts the auction. We have to provide parameters. The first one is the deadline. Let's say the deadline is slot 10, but time is measured in POSIX time, so in seconds from the 1st of January 1970, I believe, something like that. So it's not so clear what value makes sense there. Luckily, in the Plutus -ledger package, in module ledger.timeslot, there is a convenient function slot to POSIX time. So if we import that in a REPL, and we have this slot to POSIX time, and if we do slot 10, we get this value here. Probably, I think the simulation always starts at the beginning of the Shelley era. So probably if you convert that, it will be sometime summer of 2020. But in any case, we can use this value. So let's use the value here. Now the minimum bid, let's say 100 ADA. And now we must specify the NFT that's being auctioned. And because of how I set it up, this is 66 and T. So don't worry about the 66. That's just how this T was defined. Okay, now let's wait 1 block. Now let's Bob make his bid. So this is again specifies the NFT, so it's 66T. Now the bid, 100 ADA. We wait for another block. Now Charlie outbids Bob. So again the 66 and the T. And now 200 ADA. We wait until the deadline has been reached. Let's wait until, just for good measure, until slot 11. I'm not sure whether 10 would suffice. It depends how exactly before and after the deadline is defined. And then Alice or Bob or Charlie, anybody can invoke close, but Bob has no reason to. So it will be Alice or Charlie. Let's say Alice. So she invokes the close endpoint. Again, 66T. And let's wait for one more block. And let's evaluate. Okay, now we see the transactions that were simulated. We see there were 1, 2, 3, 4, 5, which at first glance is a bit weird because we only have start, 2 bits, and the close, so it should be 4. But the first one in slot 0 is always there. That's the so-called Genesis transaction. That's a transaction without input that provides the initial funds to the wallets. So we have these 3 outputs for our 3 wallets, and we get what we specified. So Alice gets 1000 ADA and the token, and 2 and 3, Bob and Charlie, only get 1000 ADA, but nothing of the token. So this is the Genesis transaction that always happens to kick things off and provide initial funds. So now in slot 1, this should be the start transaction. So input, we see, is the only UTXO that Alice owns, her 1000 ADA. And it contains the 1000 ADA and the NFT. So this is the start transaction. We see that fees are taken into account here in the playground, but not properly. I think there's always at the moment a flat rate of 10 Loveless, which is not realistic. So in the real blockchain, in the real system, the fee will of course depend on the transaction, how big it is and how long the scripts run, how many resources they consume and so on. But for now, the fee is always 10 Loveless. Then the second output here is Alice's change. So she gets her 1000 ADA back minus the 10 Loveless fee. And the third output is the interesting one that goes to the auction script. So now the NFT is locked in the auction script. So now if we go to the next transaction, that should be Bob's bid. So we have 2 inputs as in the diagram we looked at earlier. So one is the auction script with the NFT and one is Bob's original UTXO. And as outputs, so we again have the fees, which in this case are not just 10 Loveless. So now we have like a higher fee. So it seems that changed since last time I looked at it. So now it's not a flat rate of 10 Loveless. There is some more sophistication going on. The second output is Bob's change. So it's basically 1000 ADA minus the 100 that he bids, but then also minus the fee. The third output is the updated script. So the updated script now contains the token and Bob's bid. Now let's look at the next transaction. That's Charlie's bid. So it's similar here on the input side. So the script UTXO goes in, that at the moment contains the NFT and Bob's bid. Then Charlie's UTXO is the second input. Now we have one output more because Bob gets his bid back. So we have the fees. We have the change for Charlie. So he gets roughly 800 ADA change because his bid was 200. Then we have the script output. So the NFT is still there, but now there are 200 ADA in it, Charlie's bid. And finally, for wallet 2, for Bob, Bob gets his 100 bid back. And the last one will be the close invoked by Alice. So input is just Alice's wallet. This is in order to pay for the fees. And then the script output. And so we have the fees, we have change for Alice. So it's virtually the same that went in minus these fees. Then Alice gets the highest bid, the 200 ADA, and Bob gets the token. So the auction is finished. We could check what happens if something goes wrong, or for example, if Charlie's bid is too low, is not higher than Bob's bid. So where is it? That was here. the bid was 200. So let's say Charlie makes a mistake and only bids, instead of 200, only 20 ADA. So if we now evaluate, okay, then we see we have one transaction less. So this is still Bob's bid with the 100, but now Charlie's transaction was invalid, so that's rejected. And the close now looks different because now Bob is the highest bidder, so Alice only gets 100 and Bob gets the NFT. Finally, we can try what happens if there is no valid bid. So, for example, we can just remove the bids altogether. Let's remove Bob's bid and Charlie's bid. And we must just wait until the deadline has been reached. So wait until slot 11, let's say, and see what happens now. Okay, so we have the Genesis transaction and the opening of the auction and no bids. And now the closing of the auction will just return the NFT here to Alice. So in this case, there are two outputs to Alice's address, but in any case, she ends up with the NFT back in her hands. So you can see that this is a relatively complex contract and one that might actually be useful in practice. And it seems to work, and we can play with it in the playground. So I hope you enjoyed this walkthrough through the auction contract and are excited to learn how to do things like that or even more interesting things like that yourself during this course. And that's the end of today's lecture. So all that remains is homework.